Good morning children, this is Latha. Welcome to class 6 IIT Physics class. Children, we were discussing the chapter kinematics, and in the previous class we discussed the third equation of motion. Is it now? What is the first equation of motion, children? First equation of motion is V is equal to U plus AT. Is it? V is equal to U plus AT. Second equation of motion is S is equal to UT plus half AT square. And third equation of motion is V square minus U square equal to 2AS. Clear children? So today's class is numericals on third equation of motion. We already derived the third equation of motion in the previous class. What is the third equation of motion known as? Velocity, displacement, relation. Is it? Third equation of motion brings the relation between velocity and displacement. Okay children, so let's start today's class. Third equation of motion, that is velocity displacement relation. It is the relation, it brings the relation between velocity and displacement, that is V square minus U square equal to 2AS. What is U? Initial velocity. When a body starts moving, then what is the velocity of the body? That is called initial velocity. V is final velocity. When the body for a particular time, what is the last velocity of a body? Present velocity of the body, that is final velocity of the body. Okay. Next, A stands for uniform acceleration. Already we discussed these three equations of motion only applied for the bodies which are moving with uniform acceleration. This is a main condition it must follow. You have to remember, whenever a body moves with uniform acceleration, then only you can apply these three equations of motion. So this thing is important to remember. Next is S. S stands for displacement. Okay, now V square minus U square equal to 2AS. Final velocity, initial velocity, acceleration, uniform acceleration, and S stand for displacement. Got it children? So children, now we will discuss some numericals based on third equation of motion. So you can see on your screen, the first question is, a car initially at rest starts moving with a constant acceleration. Constant acceleration means uniform acceleration of 0.5 meter per second square and travels a distance of 25 meter. Find its final velocity and time taken. Okay now children, so a car starts from rest. We already discussed, whenever a body starts from rest, rest means a state when the body is not moving. Is it no? So if a body starts from rest, its initial velocity will be 0. U will be 0. Now the body is moving. It is moving with which type of acceleration? Uniform acceleration or constant acceleration. So now as the body is moving with uniform acceleration, we can apply any three equations of motion. So what is the uniform acceleration? 0.5 meter per second square, and travels how much distance? 25 meter. We have to find what? Final velocity and time taken. So children, you can see initial velocity is 0, acceleration is given 0.5 meter per second square, distance traveled S is 25 meter. One thing remember children, whenever you do the numericals, just like your mathematical sums, first what is given in the question. See what is written here? Given. Okay, so what are the things given in the question? you have to write first. Okay, after these three things are given in question, now after writing this, by based on these three things, which equation you can apply? You have to find V. Okay, U is given, A is given, S is given. So we will apply this third equation of motion, that is V square equal to U square plus 2AS. Directly substitute the value. Initial velocity is 0, 0 square plus 2 into A into S. Okay, so V square is equal to 25. V square is 25, so V is equal to square root of 25. We know already, if one side square is there, when you remove this square, the another side you have to give square root. Yes, square, when you remove this side you have to give square root. So square root of 25, that is 5. So final velocity is 5 meter per second. Clear? Very easy, directly on the formula. Now, second, what you have to find? Time taken. You have to find time taken. Now for second time taken, which equation we will use? Here it is better to use the first equation of motion. V is equal to U plus AT. Now we got V final velocity, U we know 0, A we know, time we have to find. So it is better to use the first equation of motion. So V final velocity we got now 5 meter per second is equal to U is 0 plus A 0.5 into T time. Okay, so 5 is equal to, first term is 0, 0.5 T. So T is equal to what? 5 by 0.5, that is 10 seconds. Okay children, very simple. Okay, so time taken is 10 seconds. Clear? Now children, you can see the second question on the screen. Second question is, a body with an initial velocity of 18 km per hour accelerates uniformly at the rate of 9 cm per second square over a distance of 200 meter. Calculate. Okay, so a body, its initial velocity is given, U is given. Initial velocity is what? U is given 18 km per hour. Okay, next, body is moving with uniform acceleration. It is mentioned that body is moving with uniform acceleration. It means we can use any equations of motion here. And what is the uniform acceleration? 9 cm per second square. Distance is given 200 meter. We have to find acceleration in meter per second square and final velocity in meter per second. Now you can see the units, children. Units here, initial velocity kilometer per hour. We have to, when we do numericals, we must convert everything, every quantities in the SI system. That is better. SI system, if we will convert, it will be better for you. So we have to convert. First, acceleration given what? 9 cm per second square. So 9 cm per second square you have to convert into meter per second square. Okay, so you see, centimeter to meter. How to convert centimeter to meter? Divide by 100. Is it no? 1 meter is equal to 100 centimeter. Then 1 centimeter is equal to 1 by 100 meter. 9 centimeter is equal to 9 by 100 meter. Okay children, very clear now? 1 meter is equal to 100 centimeter. Then 1 centimeter is equal to 1 by 100 meter. Then 9 centimeter is equal to 9 by 100 meter. So 9 by 100 meter per second square. 9 by 100 means 0.09 meter per second square. Okay, so first one we got acceleration 0.09 meter per second square. Next, initial velocity is given in kilometer per hour. That one we have to convert into meter per second. Okay, now SI system. So kilometer to meter. 1 kilometer is equal to 1000 meter. Once again, 1 kilometer is equal to 1000 meter. 18 kilometer equal to 18,000 meter. Okay, so meter is it is converted, kilometer to meter converted, 18 kilometer equal to 18,000 meter. Now per hour means 1 hour. Now you have to convert into second. 1 hour equal to 60 minutes and 1 minute is equal to 60 seconds. So 1 hour is equal to 60 into 60 seconds. Now when we calculate, we will get 5 meter per second. So acceleration, we got 0.09 meter per second square and initial velocity is 5 meter per second. Okay. Now distance is already, S is given 200 meter. Okay. What we have to find? Final velocity. Final velocity. Now see which equation we will use. Third equation of motion is exactly correct. V we have to find. U we have 5 meter per second. Then A we have 0.09 meter per second square. Distance S also we have 200 meter. So all these are there. So directly we will use third equation of motion. So U square 5 square plus 2 into A into S. So V square equal to 61. Final velocity V is equal to root 61. Its approx value is 7.81 meter per second. Clear children? I hope you are understanding. Very simple numericals are there. These are. Now children, you can see on the screen the third question. Third question is also very simple. A ball is thrown vertically upwards. It goes to a height 19.6 meter and then comes back to the ground. Okay, a ball. When a ball is thrown vertically upward, it goes to a maximum height. You know, whenever you throw anything upward, it will go to its highest point. Okay, with what velocity you will go? You will throw the body upwards. When it decreases its velocity, when a body goes up away from Earth, its velocity is continuously decreasing. Now it will go to a highest point. One point will come, that is on maximum height. At that point, its velocity becomes 0. Then after, it comes down. Okay, and when it comes down, its velocity slowly increasing. When it comes down, it comes towards the Earth, its velocity increasing. Okay, so here you have to, what is the height, up to what height ball went? 19.6 meter. You have to find initial velocity of the ball. Okay, then total time of journey and final velocity of the ball when it strikes the ground. Initial velocity means with what velocity you thrown the body upwards. Okay, initial velocity. Final velocity, with what velocity the ball strikes back the ground. And total time of journey means time, the time of ascent plus time of descent. Time to reach highest point again plus time to reach the ground. Both we have to add, then we get total time of journey. So let's start. First, what given? Height is given 19.6 meter. Acceleration, here it is the body is working under the gravity. Okay now, so acceleration compulsory, acceleration due to gravity. Okay, so when the body is going up away from Earth, so as body is going away from Earth, your G will be negative. Already we discussed, children, in the previous classes. When the body is going away from Earth, body is going up away from Earth, then acceleration will be negative. Okay, so minus G, minus 9.8 meter per second square. Now V, the final. Okay, final V is here 0. Why it is V here 0? When the body reaches at this height, already I said, when you throw a body, its velocity going on decreasing. When body is going up, its velocity going on decreasing. At the highest point, its velocity will be 0. That's why here V is 0. Okay. Now this is the thing when the body is going up. Okay. So V is 0, final velocity is 0. U, initial velocity, you have to find the velocity with what body is thrown upward, minus. Okay, here plus given and here minus given. Why? because here G is given, but G is which type? Negative G. That's why here minus came. Okay, 2 into minus 9.8 into 19.6 height. So when we solve, we will get u square equal to this much. So u is equal to, initial velocity is 19.6 meter per second. It means when, with what velocity you throw the ball upwards, 19.6 meter per second. Okay, now next what you have to find, second question, total time of journey. So let t second be the time taken by the ball to reach the highest point. When you throw the body up, okay, it takes t seconds to reach highest point, height 19.6 meter. To go to the 19.6 meter, it takes t second time. So from first equation of motion, v is equal to u plus gt. V final velocity, okay, u initial velocity plus gt. Okay, so u we got, now we calculated u 19.6 minus g, once again minus g. Why? Because body is going up away from earth, so minus g, minus 9.8 into time t. So by this we got t is equal to 2 seconds. Means it takes 2 second time for ball to reach the highest point. Now total time of journey, t dash is total time of journey, 2 times 2t, 2 into 2, 4 seconds. Now why directly multiplied by 2? Because how much time body will take to go up, that much time only body will take to come down back. Okay, that's why multiplied by 2 and we got 4 seconds time. Okay, so total time of journey is 4 seconds. Now third one, you have to find the final velocity of the ball when it strikes the ground. With what velocity ball is striking the ground, that is final velocity. That one we have to find. Will be same as the initial velocity with which it was thrown upwards. See children, whenever you throw any body upwards, with what velocity you are throwing the body up, with that much velocity only body will come down. Remember, with what velocity you are throwing a body up, with that much velocity only body will strike the ground back. Okay, that's why here initial velocity when the body is going up, that is, and the final velocity when the body striking the ground, both will be same. So here final velocity is 19.6 meter per second. Clear children? Here two things is for you. You have to remember. First is time of journey means time of ascent plus time of descent. Time of ascent means time taken by body to go to highest point is time of ascent. Time of descent means time taken by body to come back to the ground, that is time of descent. So when both you will add, you will get total time of journey. Whenever any body you will throw up, how much time taken by body to reach highest point, that much time only body will take to strike back the ground. Okay, and second point what you learned, whenever you throw any body up, with what velocity you are throwing the body up, with that much velocity only body will strike back the ground. Okay, when the body is going away from earth, going up, that time its velocity going on decreasing. The maximum height when it will reach, that time its velocity will be 0. Then after it will come down. So when it comes down, its velocity is going on increasing. Okay, so these are the 3 numericals children we discussed today. I hope you understood well. These 3 numericals only I am giving as a reading work. What you have work is these 3 only. Once again you have to practice. I have given 2 times to practice. Very important. These 3 numericals only 2 times you have to write and practice in your notes. Clear, children? So these are the numericals on third equation of motion. This is for today. Thanks for watching.